trying to demystify the complexity that comes with them. So let's talk about the first three things. We're gonna be understanding what an integer means, what a float means, and what a vector means. So an integer. Integers are set numbers. So for example, a 1, meaning a number that doesn't have a point something. So it can only be a 1, 2, and 3. It can't be something like a float. Like for example, floats can be a 0.1. Okay, a 0.1 or 1.1 or 2.2 or whatever, but it can have a point something. So it is a divisible number. Okay, and a vector has three values. So x, y, and z. It can be anything. 5, 3, and 2. But it just has three values. So this is the basics of understanding how wrangles work inside of Houdini. Integers, floats, and vectors. Integers are whole numbers. Floats are point something numbers. And vectors are x, y, and z numbers. They have three values. So the first thing that we're gonna do is we're going to create our first attribute. Okay, so for the creation of our first attribute, we're going to be declaring a value. So for example, f, we're gonna start with integer. So for example, I, which stands for integer, at whatever attribute we want to be called. So I'm gonna say attribute I for integer. This number, this whatever I'm typing here, it can be anything. The important thing is to tell Houdini we're gonna declare an integer at whatever name we want it to be, and will be equal to a 1, and then a semicolon, which is something that we've always got to put down inside of Houdini. So let's put this on a wrangle and see what we get. So I'm just going to create a box, set it to polygon, turn off the normals, set up a wrangle, okay, and paste it here. I at attribute is equal to 1. And then if you hit Control Enter, boom, it calculates it. So nothing happens, right? But if we come here into the geometry spreadsheet, if you click this and you say geometry spreadsheet, we see that we got this thing was created. So if I do 2 slashes here, it means it comments the thing out, and you see it just removed the attribute. But if we leave it here, we know that it created an integer attribute that we called atti for attribute integer is equal to 1. Just so that you can see that this can be anything, we can say x, and you'll call this attribute x. But we'll call it attribute integer so that we can call the other ones appropriately, just for the sake of understanding what we're doing. So the second one that we're gonna create will be our float. So we're gonna say f at attribute float is equal to a 1.1. Okay, so I'm going to copy this. Okay. And you can see that our float value can have a point number. If I come here onto my integer and I say 0.5, you see that we get an error. The integer cannot calculate, it can only calculate whole numbers. So this one can be anything, like 2.5. You can see our float has a 0.5 value. Okay, and we're gonna repeat this process into our vector. So we're gonna say v at attribute vector is equal to, and then we do 1, 2, 3, or whatever, right? Close, and we're gonna copy this and paste it and hit Control Enter. So you can see that we get our attribute v equals 1, attribute 0, 1, and 2. Okay, so x, y, z, or 1, 2, 3. 1, 2, and 3 in terms of numbers. 1, 5. We can 1 and the 5, and we get the 5. You know, we can dictate whatever we want this to be. Important thing to remember is that in computer math, we start counting from 0. So we always have 0, 1, and 2. Now we're going to be creating variables. So we're going to first create an integer variable. So it can be something like integer var a is equal to 1. And then our float value, because we have integer, then the float would be something that we say float var b is equal 1.1, and vector var c would be equal 1, 1, 1. So if we copy this and we paste it here, integer variable a, let me see why I'm getting this error. Okay, so that's not a semicolon. There we go. So for example, these are all variables that I am evaluating only inside of my wrangle, so we wouldn't be able to see them here. They're only calculated inside of here. Okay, so that's kind of the basic understanding of how to control integer, float, and vector attributes here. So these ones would be actually declared as attributes, so we can see it in our spreadsheet, and these ones are just here calculated only on this wrangle. So I'm gonna show you guys an example of how we could potentially manipulate a vector attribute. So something like a normal or a color is something that you would control regularly. So we come in and we set a facet sub, and we calculate our pre-computed normals. We can click here so that we can display the normals, and then we're going to be controlling the normals globally. So we do n at n is equal to 1, 0, 0. You will see that we will be manipulating our normals immediately based on this. But we can also do per vector manipulation. What does it mean? Like we can control the x, y, and z individually. So for example, let me comment this out and do something like, oh, I just want to control my x. So I can do n.x is equal 1. And you can see that now my normals are moving on the x. But if I do a negative, then they would move on the other side. But then I can also do a y, z, you can do the same thing. So you can be like x is equal to 1 at n dot y is equal to 0, and that n dot z is equal 0 or 1 or whatever. And you can see that now we get them moving in that direction. So the reason why Houdini understands that n is a vector and we're not actually having to declare it as such, it's because Houdini has a set of attributes, global attributes, which it already understands it is a vector or an integer or something like that. So for example, like p, and I'll put this down on the description down. For example, Houdini understands that p is a vector value and it stands for the point position. Houdini also understands that normals, which is the one that we just manipulated, is also a vector and it stands for our normal direction. V, not capital V but lowercase v, would be a vector value as well, and it's equal our velocity. These are global variables that we're going to be manipulating a lot, but it's important to understand that Houdini already knows is a vector. But it also, for example, things like ID attributes. This is equal to our integer. So this is something that Houdini knows it is an integer and it's a unique element, ID. It is something that you can assign to the points to keep track of them. You can assign to the points to keep track of them even if the point number is changing. Other attributes are, for example, name, which is a string, piece, which is integer, p scale. And remember, for example, p scale is an attribute that allows you to control the float value of the particles or the point size in a uniform scale. But then when you use the scale attribute, it is a vector and it allows you to control the scale on a non-uniform. All right, so this is basically a very superficial introduction as to how to start understanding the use of wrangles inside of Houdini, and the main introduction to learning what an integer is, what a float is, and what a vector is. And then we're going to be looking deeper into these concepts. But the last thing I'd like to show you guys is that in attribute VOPs are essentially the same thing as wrangles. The only difference between VOPs and wrangles is that wrangles uses VEX. So this code right here is what we call VEX. It's a VEX code. And wrangles and VOPs uses VOPs, which stands for visual operators. And when we connect this here and we come into the VOP network, we're gonna see that we have our global attributes, geometry VOP global. So this is where we can see that we have PV, force, age, life, ID, CD, UV. These are all global attributes that Houdini already knows what they mean. So if we see that they are all different colors. We put our cursor on top and we see that the green, for example, is a P and it stands for vector. V is a vector. Force is a vector. Age, for example, is a float, so it has a slightly different color. An ID, for example, is an integer, so it's a blue color. So we can see that this idea and concept of vector, integer, and float is going to play a huge value even when we go into VOPs operations, which is coding but visually. All right, I hope that you guys have enjoyed. Please leave any comments if anything comes up, and we'll be back with more.